Okay, hello everyone. Okay, I hope you already scanned the QR code. Okay. Before we start, actually there is I have a questions actually. Wait a minute. Okay, so um, on your quiz one, there is still two students. They didn't use real name and they didn't also input any student ID. So I don't know who they are. So if you still not getting the final score from me, maybe you can check with me whether you are one of those students who are not using their real name or student ID. Okay. So, okay, I hope in the future you are going to use your real name and also include your student ID. I forgot to mention that you need to include your student ID. So in quiz, exam, please use your real name and include student ID. Okay, if you know maybe that's your friend, please let the students know that I will not give any score to the students. Okay. Uh, Also another thing is uh, next week we are in November, right? So we're still on chapter 3. Maybe this week we will finish, maybe, okay. Or maybe next Monday we will finish the chapter 3 and then going to chapter 4. So we still have uh, some sections on chapter 3, okay? The uh, the derivatives part, the related rates, okay? So I will skip 3.7. I will skip, so it will not be in our evaluations. 3.8 also skip, and then we are going to go to related rate. So after we finish with the logarithm, inverse trigonometric, we are going to have uh, sections on related rates. Okay, and then we are going to have the linear approximation. This is, I believe, 3.10. And then 3.11, it's about the hyperbolic functions. I will skip. Okay. It's actually not really, not practically useful because the idea is still similar with trigonometric functions on derivative. So we will just skip that. And after that, we are going to go to chapter 4. And hopefully in November, after we finish chapter 4, we will have midterm, chapter 1, 2, 3, and 4. This will be in the midterm. Our midterm will be a physical exam, but for those of you who are still doing online because of you're not still you're still you're overseas, uh, don't worry about that. Okay, I will prepare something for you. It can be either doing it online or um, you will get additional exam later on when you are arriving arriving on Taiwan at Taiwan. Okay, okay, that's just a little bit introductions on what we are, what progress we are in, and how we are going to move from this chapter 3 to 4, and then from 4, hopefully uh, after the midterm, we can start chapter 5. And for the midterm itself, the school start from I think 10 or 11. I forgot 10 to 16. I think this is the midterm week. But I think because the rest of your courses will be doing on this week, so I think I will take another week. Take another week. So maybe from maybe from 20 something. So maybe from 21 to yeah this week, yeah, 21 to 27. So for this class, maybe on Monday. Maybe on Monday. Maybe Monday, November 21, maybe. Okay. So I hope finishing chapter 3 this week, and then next week we can start chapter 4. Hopefully we can finish uh, before 21 November. Okay, before 21 November. If not, maybe delay 1 week again, maybe around this 28 between these two. Okay, and I hope everyone pay attention carefully. Read the description whenever I post something online, either quiz, assignment, or anything. Please pay attention. Okay? If you are not really doing what needed in the descriptions, then you will not get full point, or maybe you will even get 0 because of that trouble. Okay. If you have something to discuss, not really understand what to do, you can still email me. Okay, just email me if you still confused. Like I think 2 or 3 students, they didn't pay attention to the quiz and they forgot to check in the quiz and they are missing their quiz. Okay, so sorry for them. Okay, so sorry. And you didn't ask me for anything. You didn't email me. I cannot do anything because I know someone tried to click my quiz to answer the quiz, but it's already expired. Okay, and you are still not emailing me, and yeah, so I hope you don't make that mistake again. Okay. Okay, we can start now reviewing our subject. First is the feedback time. The question is finding the equations of the tangent line, a typical question in calculus. This is the curve, and this is the point. And we first find the first derivative. Okay, done. I think that's too crazy, right? And then put in the x equal to, you get the slope, and then put into the line equations, you get the line equations. Directly get the line equations, you get 2x minus 1. Okay. I think not too difficult, this one. Okay, right? And then the true or false, okay? Still you answer true a lot more than false. Okay, so let's check what we have done here. So this is an exponential. Okay? This is exponential. It's different from, for example, you have 3 or x squared or x cubed. When you derive this, you get 2x, 3x squared. You are doing the power power rule, right? But of course, didn't really care about the name. As long as you know that this is the derivative, that should be fine along the semester. But here we have actually similar to power rule, right? And because this is exponential, this is wrong. Okay? What we should do is we need to write that the same variable then with the power of x, and then using the ln 10 or some constant here, right? Okay, that's the second question. The third question is a little bit calculations, and you need to be careful. You have some information for f and g, right? Some number, some evaluations, and it just the ask the question asked is find the first derivative of the composite function. So this is the composite derivative. Okay, I think not so difficult to doing this, but careful when you are doing the calculations. And careful seeing this and this. Okay. F and F prime. This is F prime, so you need to look at this 4. So 4, and then G prime 5 is this 6. So you are going to multiply 4 and 6, it will be 24. Okay, and then congratulations for the winner. Hopefully when we have the midterm, I can prepare something special for anyone who are winning the game at least 2 or 3 times. Okay, okay, now we are back to our chapters. Let's see what we are. Okay, so last time we are doing the logarithmic derivatives. We are doing this. Uh, and then the idea for this is we can actually use the ln AB, A over B. So you have ln A minus ln B, and then you have more simplified equations to be derived. So you can derive very easy if you have this separated, become A and B each. Okay. Okay. Now we start with today we start with the functions. You have ln and then absolute value x, and then I think I already mentioned that one. This is one of important to notice, okay, especially when you are moving to integral. Okay, so if you have these functions, ln and absolute value x, and then it's asking what is the f prime x, right? So what is the first derivative of this ln? Okay, now the idea is the absolute value will have at least 2 functions inside. The first one is just ln x. The second one is the negative part. Is right. This is if the x positive, and this is f negative, right? Because ln need to be greater than 0, right? inside the ln, they need to be greater than 0. So if you look here, and you're going to derivative, the first derivative of this, you want to derive the first one. That's easy. We have done last time. This is 1 over x, right? So x is greater than 0. And what will happen with the negative 1? Remember that we have this negative, right? So we are going to have 1 over negative x. And then we need to multiply. We need to multiply with d dx negative x. We are going to have chain rule. And this will be the same 1 over x. Okay, agree? So this is for x less than 0. Okay, so the f prime x is 1 over x for all x except it should not be equal to 0 because it's 1 over x. The domain cannot be x equals 0, right? And if you see the graph, look here. If you see the graph here, this is ln x. This is ln negative x. Okay. Notice that they both are actually similar. The difference is just the x. Okay. And the f prime, it's true. This is the f prime, 1 over x, 1 over x. They can have these two graph. And when they going to approach 0, one graph going up, one graph going down. And also, if you think you can find the derivative, you can just imagine first is this is the gradient or the slope. The slope is changes. It changes towards horizontal, which means it's positive, right? But it's going to have a minus, 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 but still positive. And you'll notice that still in the f prime here, they are still in positive, right? And also here, I have the slope, slope, slope. Because you will notice that there is no slope that really equals 0 here. That's why the graph is not crossing the 0, okay? Not crossing the 0, the derivative. Okay. Okay. So what's important about this phenomenon or what these findings? Okay. So if you have, so you know that, let me write here. d dx of ln x is 1 over x. If you imagine integrations, let me introduce the integral a little bit. Integrations of 1 over x and dx. Okay. If you follow what we have done here, we have 1 over x and 1 over negative x. If integrations is undo your derivative, this will be ln x plus a constant, right? But remember, your derivative here has the same 1 over x. So it should be better if you write ln and then absolute value x. Later, I will elaborate this in the integration part. But for now, this is one to notice that this is important, the ln absolute value x. Okay, now the next thing, we still in the logarithm. I will give you another example on how we actually can simplify our solutions. Okay. So it's called this logarithmic differentiations. Okay. Blah 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 blah. If you don't really want to read this, that's okay. Let me just give you some intro. So if I have y is a function of x is equal to okay. Now how to solve this? This is, I think, really complicated. You have square root, you have exponent. Oh no, not exponent. You have a power. It's a rational function, right? So what you do? Read this, take natural log of both sides, and use the logarithm to expand the expression, and then use implicit differentiation and solve the result. So first, let me just write one more time here. So take ln and take ln both sides. So we can have ln y equal. So all the things here we can break down, right? We can have 3 over 4 ln x plus half ln x squared plus 1, and then over that will be minus. Let me move this a little bit to the left. Minus 5 ln and then 3x. So if you see this sequence here, it's basically basic logarithm derivative. You can solve this easily, right? Solve easily. So what we have done here is actually, if you see any complicated functions involving any power, for example, if you have like y is f of x and then g of x like this, you can take this with ln, and you can get this expression, and then you can use implicit differentiations, and you can solve this one by one. Okay? Of course, it will include y. So whenever you find y in your equations, you can go back to see what the definition of y. Okay? I'm giving you the, let me check. Okay, so when you have this implicit differentiation, also this ln, we can prove most of all derivatives rule. Okay, derivatives rule. We can prove. Okay. For example, ddx x with power of n. I believe this it should be easy because this is what you are already familiar with. But let's say we have to prove this using implicit. Let's start with the y equal x with power of n. And start writing the ln, and we have n ln x. And then start differentiating with respect to x using the implicit. So 1 over y. Don't forget dy over dx. And then here we have 1 over x and n over x. Okay, and the dy over dx will be y and x. And remember that y is actually x over n, with power of n. So you can write this with n and x, and then minus 1 from here, minus 1. Okay. You get to prove using implicit differentiation. And like I said before, we can prove most of the rules. So let's check it out. So let's check it out. So you have f of x, g of x. Let's say this is your y prime. This is a product rule. Okay. We can start using or let me just write f of x and g of x with just f and g. Okay. And start doing the ln and ln. And then we can separate this ln f plus ln g, right? The thing we can do the implicit differentiations, right? Ln y becomes 1 over y, dy over dx, okay? And then ln f becomes 1 over f, and because it's a function, then it will be f prime. And then plus 1 over d, and then d prime. And then solve this dy dx, dy over dx. Y I will move through here, so y is f prime f, or maybe let me directly go through simplifying this. And y is actually fg, so we can cancel this. So we will have dy by dx is f prime g plus g prime. Okay, and I hope you can do this by yourself, and you know that you can also derive this with implicit differentiation. So we can prove product rule using the implicit differentiation. Okay, same thing if we want to have a quotient rule. So let me make this way to the left here and make it a little bit smaller. I think some students are not muting the mic. Can you mute your microphone? Yeah, check. Okay, check. Okay. Okay, let's go to the quotient rule. This is y equal f of x divided g of x, right? In quotient rule, let's say we have, let's just write f over g like that. In, use the ln, okay, to get the uh, logarithm law, and then we can write ln f minus ln g, and then doing the implicit, and here is 1 over y dy over dx, and then this become similar with before, f prime over f minus g prime over g, right? And then dy dx is, we can, this is y, and because y is, or maybe I will write directly y is f over g, so we can cancel f, and we have our quotient rule. So whenever you forget, my suggestion is you go to the implicit to prove that. Or whenever you want to make sure how the formula works, you can check with the ln and implicit to prove. So this will be g squared, and we are able to prove the quotient rule. Okay. All right. Um, any question? Sometimes you can also think. Um, let me give you another one. Maybe let me stop here for a while for you to take some notes. F prime over f here. Okay, this is basically if you have functions ln and then function x, and you want to derive this. This is basically becomes 1 over f of x, right? And then multiply with f prime x. This is basically what this is about. Okay. Okay. Any other question? Going to here. This is basically similar with this. Similar with this. Okay. Right. I just directly write f prime over f. Probably if you want to make it going here, that's okay. Let's make it 1. It's also going here. I'll make it 1. Same thing. Same meaning. Okay. Okay. Let's continue. I want to tell you about the, oh, right. We can also look the this is just some suggestions. Okay? So we have ln, right? Or we can write y equal ln x. We can also think this in terms of exponent, So we can make it like that, right? E, this is meaning, right? Or we can just write like this. Still okay, right? That's the ln. And then after doing this, if we want to differentiate, we still can do the implicit. So that's why I've told you before. Implicit differentiation is one of the most powerful tools in derivatives. So it's quite helpful, and we can implicitly differentiate this. Don't forget dy over dx. And this is basically just x, and then this is just 1. So dy dx, dy over dx is 1 over, or we can write this. This is actually just 1 over x. Okay, we can move to I've done this. Okay. Okay. Still with the ln. Let me write one more here. We know that the f prime will be 1 over x. And when we have f prime, when x equal 1, this will be 1, right? Okay, let's start using this information to check our limit definition. So f prime 1 will be limit as h going to be 0. So this will be 1 plus h. So we are going to have x equal 1 minus f1, and this will be h. And then uh, let's take x, changing h with x. Okay. So we want to evaluate the x, and change the functions. So f is ln, so we can move to change the f to ln1 plus x, and then minus ln1, basically 0. But let me just write first. So we will have limit as x approaching 0. We will have 1 over x ln 1 plus x, right? We can rewrite this because because of the logarithmic rules. We can write ln 1 plus x, and then this is 1 over x going up. And because this is equal 1 of our f prime 1 is 1, so here, remember, okay, in exponent, you have e, you have e with the power of 1, and 1, you can express 1 in terms of the limit as x approaching 0 of ln 1 plus x with power 1 over x. And in limit, and because of its exponent, we can say that this is also true. That this is actually going to equal limit as 1 plus x equals 0. When x approaching 0, this is 1 plus x with power of 1 over x. So our E can be also written as, so this is another way to write down the number E. Or if, okay, if as, or maybe if x, n, sorry, n is 1 over x. So as x going 0, n will going infinity, right? So we can also approach this in terms of n going infinite, 1 plus 1 over n, and this will be n. This is also E. And E is 2.71828, I think 1 and 8, and a lot of numbers. This term is actually, we can also find from compound and interest. If you are interested to look on how it's done, you can check some, I think, a lot of videos of explaining this compound and interest, and they found out that they can get this E from those phenomena. Okay, now we move to the inverse of trigonometric functions. Okay, now let's move to next one. Here we already done this. Now okay, we are going to use this. So inverse of trigonometric function. Okay, if we look on the graph, let's just say we have the graph of sine or cosine, maybe sine like that, right? Going here, going there, yeah, something like that. This is 0, pi over 2, pi, and so on. If you remember, if you want to have an inverse, the functions need to be one-to-one functions, right? if you look at the whole functions here, the whole function of sine, when you take a horizontal test, let's just say we have this test like that, we are going to cross a lot of points, right? A lot of points, up and down, a lot of points here and here. Okay. One way we can make the functions to be one-to-one functions is making restriction, or we make a restriction on the domain. Okay, so restrict the domain so that function is one-to-one. For example, if we are restrict our domain maybe uh, from this part here uh, and here, so from maybe negative pi over 2 until pi over 2, so maybe here. Okay. Now our function is one-to-one functions, right? Our sine x is one-to-one function, and by doing that, we can make our inverse. How to make an inverse? If you want to make an inverse from the graph, you can mirror doing some reflection. Uh, you can reflect to y over x. Inverse, you can doing the reflecting functions to y equal x. Or if you are just looking at the equations, if I say y equals sine and then inverse x, okay, this is inverse, okay, this is inverse. It's not 1 over sine x, okay, so this is wrong. Okay, so it's inverse means sine y is equal x. Okay, hope you get my point. So this way, the inverse, we are going to look for the angle, right? The angle. Okay. Okay. We are doing. We can do this if you want to take derivative ddx like that. We can make it becomes cosine y, and then dy dx, and then 1. And this way, we can have dy dx equal 1 over cos y. Okay. Now, cos y, we can do several ways here. Uh, but we need to define what is this cos y here. So what I would like to do, and I prefer to do doing this way. It's up to you. Actually, I will show you another perspective. I will do it with help with the help of a triangle. Okay. First, look at the first definition here. Sine y is x. Sine is if my angle is y here, right? Sine y is x over 1, right? So x and the hypotenuse will be 1. And the other side will be 1 over 1 minus x squared, square root, right? Okay. So I can take the other definition of cos y is the square root of 1 minus x squared. And then we can write this become 1 minus x squared. Okay? You can also think, not using any triangle, you can also think because y is uh, at least 0 or greater 0, sorry, not y, cos y. And y will be from negative pi over 2 until pi over 2. We can take this into our identity, and we can take this cos squared y is 1 minus sine squared. And our cos y is square root of 1 minus sine squared y, which is our x. It's actually a similar approach, but I would like to have this in my preference. Okay? But actually, it's up to you. But my preference is always to look at the triangle, because you know that the angle should be in a acute angle, right? Because it's an inverse, so that your domain should be there. So you can always use the triangle. Yeah, that's the sine inverse. Okay. Okay. Any questions first? Any question first? Yes. This. Oh, this is because the domain. This is because, okay, so someone asked why we are going to limit this in between minus pi over 2 and pi over 2, because we are restricting our domain here. This is negative pi over 2, this is pi over 2. If you are going to look for every possible way, actually you can limit here, right? You can also limit here, but in our default functions, okay, we are going to limit at this very minus pi over 2 and pi over 2 for the inverse trigonometric functions, so that the functions is one-to-one functions, and because it's one-to-one function, you can have the inverse. Okay, that's why. Okay, we still have much time. I think we can finish the inverse today, and maybe going a little bit of related rates. But related rates problem is basically how you are understand the uh, the problem from maybe some complex rate of change, and then you can use some formula to differentiate. Blessing, you want to ask? You raise a hand. Okay. Hello, Blessing. Do you want to ask something? No. Okay. Okay. Let's continue a little bit. Okay, let's continue with the other one is, let's say we have the tangent inverse x. It's asking what's the first derivative of tangent inverse. Or some of you prefer write in terms of arc tangent. It's still okay. Still okay if you want. But in the questions, if I make some question, I will use the tangent inverse. I prefer this. It's more mathematics. Okay. Okay, F prime. So we are going to have, let's say y is our tangent inverse x. Okay. So we can make the triangle first. Okay. To make some definition here. So y will be here. Y is tangent inverse x. So tangent y is x, right? X over 1. Okay. So this will be, maybe I'll use different color. Let's say green. Okay, let's say this x and then 1, right? And this will be x squared plus 1. Okay, now let's start to differentiate uh, tangent y equal x. Start to doing some implicit. Tangent, it's secant squared, right? Okay, whenever you are not remember what is derivative of tangent, you can always doing this sine d du. Okay, let's just say this is x. Okay, and this will be cos squared x. Doing some quotient rule here. This will be cos squared x, and then minus minus minus. So it should be plus, right? This will be 1 over cos squared x. This is secant squared x. Okay. So we can write this is secant squared y. Write dy over dx, and then 1. So dy over dx is 1 over secant squared y. Or if we look here, let me write this whole thing here and make it small. Okay, maybe here. Okay, start with cosine y is uh, 1 over, and here we go. We are getting the tangent inverse to be 1 over x squared plus 1. Okay, so you have sine inverse, tangent inverse. You can do the same thing with cos inverse, right? But I will let the cos inverse for you to check how. Okay. But the idea is, if you see what we are doing here, I think the easy way, one of the easy way is, uh, whenever you forget, you can go back to this triangle, okay, and find the derivative. I think the tangent inverse is simple enough to be memorized, but I'm not forcing you to memorize this, and I hope not, because actually, like for example, the sine inverse. This is sine inverse, but sometimes I forget the sine inverse. For tangent inverse, is just 1/x²+1. It's not too difficult because it's the tangent. But because sine inverse has some complementary with the cosine, so sometimes you can have mix up between sine and cosine. So be careful and always check this triangle here. Okay. And here's the functions that maybe you will need to check. Uh, I think the left one here is, I think, important, especially the tangent inverse. Okay, especially tangent inverse. The right one here, the cosecant, secant, cotangent, it's not really that often, and as long as you find with the left one, you should be able to check. Why we use tangent inverse x, but not tangent inverse tangent x? Mm, isn't it the same? Okay, let's check this. Okay. Um, it should be the same, but it's actually depending uh, on how you are going to get through the expression. Um, for me, I want to take the derivatives to be focused on the tangent inverse. I need to emphasize the tangent inverse. So I need to use the, so let me write here. So tangent, right? This is what you mean, right? So this will be tangent y, and this will be x, right? And then y, not tangent inverse, and then tangent x. Why not this? Because I want to emphasize the tangent inverse. Okay, I want to emphasize tangent inverse. This is what we are going to prove on. Okay, I hope that's got into some uh, some understanding with that. Okay, so I want to emphasize this, okay? And because this is the problem that we are going to working on, right? Okay, not the tangent x. But actually, if you want to take from there, it should be the same expression, but you will be maybe mixing x and y. Okay, maybe we'll be mixing x and y. I want to be precisely has tangent inverse x. Okay, I hope that that's clear. Okay. Okay. Okay, we are here, and okay. So basically, the inverse. Okay. Okay. And also, remember that uh, this is the basic inverse. Okay. If we are going to have some practice or maybe some example for you, you can take this. Maybe you have sine inverse, but maybe let's say x cubed, for example. That means if you want to have derivative, then this will be 1 minus. This is x squared, so x cubed, and then squared, and then 10 rule 3x squared. So we can also combine this inverse with other problem as well. So yeah, that's why sometimes you need to have some practice. I don't want you to have like really long practice. As long as you get the idea and you get to familiarize with, that should be fine. Should be okay. Okay, again, let me remind you, we are skipping 3.7. And then we also skipping 3.7 is just some additional information. It's about the rates of change in science, social science, in nature. Um, I will just simply skip all of that. It's more physics, biology, economics. So I will not going through that as well. And 3.8, we are going to skip it also. This is about the exponent growth and decay. We don't have time to check this. But actually, this is if you want to know more about how the nature, like populations grow, like in bacteria or maybe in radioactive, the decay, you can check this out. And I think in physics, you also already learned. And then the compound and interest. Okay, if we still have this, maybe next time in maybe additional video, but I'm not planning to give you uh, this chapter. Okay, we are going to, so from 3.6, we are going to move to 3.9, which is the related rates. Okay, so I think I will move to the next page to make it uh, clearer. So related rate, if you look at the words, this means we are going to look on, there will be a rate of change, okay, rate of change. And it's not one, maybe it's two, three, four, maybe more. And we are going to relate this rate of change, relate, relate the rates in a, let's say formula or equation. And then, and then check the information, which means the information is if they are talking about length, how much the length is, or how fast, or how big, like that, those informations. It can be anything. Okay, perhaps it's not really informative, not really understandable from this word. Let me just give you an example. And I believe this is a subject that uh, easy to follow, but not really easy to understand from the point of the questions. For example, okay, let me start with the example one. Air is being pumped into a spherical balloon so that its volume increases at a rate of centimeter cubes per second. The question, how fast is the radius of balloon increasing when diameter is 50 centimeter. Okay, now the difficult thing on the relative rates is to read the questions. Okay, to read the questions, that's the, I think, difficult if you don't understand what it means and maybe what's the purpose. Okay, so first read the questions carefully. So air is being pumped. Okay, so there is an air being pumped into a spherical balloon, and when air is being pumped, the volume increase, and we have the rate of that volume, right? This is rate of volume. So we can have this rate of volume, right? Is 100 centimeter cube per second. And then what's the question is how fast is the radius of balloon increasing? So rate of change of radius. So the r dt when r is 25 or diameter is 50. This is the question. So this is the given information. This is the one that we want to solve, right? One to find. And sometimes you need to draw the sketch if you need to. But I think for this case, you don't really need to draw the sketch. You just imagine there is a balloon, and we are going to make it as simple as it is. So yeah, just balloon that is perfect sphere, not having any defect or anything, right? And you just want to know the so this is maybe this is the pump. So the pump giving air, and then it will change a little bit, right? Change the volume a little bit, right? Probably from small and then until this big, right? Until the radius is 25. And then we need to connect the dv over dt and dr over dt. Of course, because it's volume, to connect volume and radius, we just need to look for volume of sphere, right? That's the simplest one that we can connect with. So we can connect with the volume of sphere, and then we differentiate with respect to t. So dv dt is 4 pi over pi r squared, right? 3 is cancelled, and then dr dt. And then we can solve dr dt. And then plug in 25, and this will be 1 over 25 pi. Dr dt when r is 25. So if you want to completely write, this is centimeter per second. So this is the whole page if you want to look at. And if you check the questions, maybe later, maybe next week, maybe I will give you maybe some example on questions in. It's not an maybe not assignment, but I'm just giving you the questions, and you can look at the question. In related rates, usually um, the idea is there are several questions that usually we are going to look for, and usually that is the question in related rates, like the balloon, change in volume, change in area, the ladder, and then the shadow, like when you have a man walking, the shadow is getting longer and longer when you are having light. And there are other several questions that I think it's typical question in related rate. If you already master all those type of questions, I think related rate should be not that difficult. The difficult thing again is when you read the question, do you understand or not? If you already take some time to check the questions, the typical questions, I think you should be okay. Right? Okay, next section. Maybe I will just give you 2 or 3 examples. Maybe I'm giving you this strategy first. I think you, this is reasonably correct. Okay. Example 2, I haven't give you example 2. but I will give you this problem first. So the strategy for solving related rates problem, first is of course read the problem carefully, draw a diagram if possible, and then introduce notation, which means name all the things that are possible to be quantified. Name giving symbols, and all should be with function of time, maybe phi, and other also. Express the given information and the required rates in terms of derivatives. Uh, this means dx dt or dy dt. Okay, and write an equation that relates. You can use any geometric formula, maybe from maybe area, maybe volume, or maybe Pythagorean theorem. Okay, and then using chain rule, differentiate with respect to t, and then substitute the given informations and calculate. Okay, basically that's what we are going to do. So read the problem, draw a diagram, name all notations, uh, use any formula that can connect all, differentiate, evaluate, and then that's all. Okay. Another example that are typical is the ladder. I think I've given this ladder problem when we are in implicit. So I hope you still remember. So, so if this is a ladder, this is a wall, this is a ground. The ladder will comes down here. Let's say we have some dy dt, okay. And then we can connect this. Maybe this is a constant here, any constant. We can connect this with the Pythagorean, and we can simply differentiate both sides, and we get this. And depends on the question. Like for example, if this is asking dy dt, and this part here already fixed as maybe a, then we can use that knowledge to look for here, and we know the length here. We know the length, uh, maybe u and v, and we are going to put all here, and we can find dy dt is equal with something. Okay, this is the case that we can have. Um, okay, another example is a water tank. That's actually we can have that typical questions also. Let me just screenshot this first and then give you the. Okay, let me take it to here. Okay, a water tank. Okay. Okay, let's read first. Let me give you time to read the question first. So first you need to read and then understand what the question means. Okay. So you have a water tank, and what the shape of water tank? What is the shape? The shape of inverted circular cone. Okay. So whenever you read any related rate problem, do not be overthinking, right? Just think as simple as possible. So if you say a circular cone, then you can just imagine like just really like circular cone like that. And then if say inverted, then we are going to have like that. Just invert. Okay, just invert the cone. Okay, that's how it is. I think that my cone is bad. I'm going to draw one more time. And then you have base radius is 2. Let's just draw one by one. Radius is maybe here. And let's say that is 2. Okay. And the height is 4. Okay. And it has water. So let's draw some water, or maybe a little bit up so you can see clearly. Okay, so maybe there. Okay, this is the water here. Okay. And then you have some variable h here that it can goes up and down, right? According to the level of water. And this will be having uh, the diameter of the or the radius. This is just r. Of course, r is also can be changed, right? According to the water level. And the questions or the information is water is being pumped into the tank at a rate of 2 meter cubic per minute. Find the rate at which the water level is rising when the water is 3 meter deep. So the height is 3 meters. So we are given that the volume will be having 2 meter cubic per minute for its rate of change, right? And then what we need to find is we need to find the rate at which the water level is rising. So how fast the height, the level, it changes, right? So we are going to look for dHdt at h equal 3 meters. This is the question. Okay. So I hope you get the idea from the question. And then to connect all of this, we can think on from here, we have a circular cone that has the radius of r and then the height of h. And if we are going to write down the formula of volume, it will be for cone 1 over 3 pi r, the area pi r squared multiplied with the height, right? Okay, I hope you still remember all the at least basic for any geometric, right? Geometry formula for cone, triangle, okay? So area, volume, right? Okay, but we are having R and H together, right? In this volume formula. We want to have only one that are fixed as a variable. What we are going to do now, you see we have at least R, H, right? And we have another one here. This is 2, and the total of the water tank is 4, the height. You can also doing this triangle property, right? This is R over H is 2 over 4. And you can make this R becomes H over 2. So we can also write this in terms of, we can have in terms of R or in terms of H, but I will maybe in terms of H. So this will be H over 2 squared H, or this will be pi over 12, 4, 3, and then H cubed. Okay, when we have this, volume is pi over 12 H cubed. We can both sides differentiate with respect to t. We get dv dt, and then we get pi over 12. This is 3 H squared dh dt, and dh dt will be, this is 4, 4 pi h squared dv dt. Now dh dt at h is 3 will be 4 pi 9, and then dv dt is what? Dv dt is 2. Dv dt is 2, so this will be 8 over 9 pi meter per minute. Okay. If you have any pi in your results, okay, uh, you don't really need to calculate until maybe you want to divide 8, 9, and then 3.14 something number, and you want to have the number 0.28 something here. I don't mind having this, okay, as the result. So no need to calculate the pi. Let me give you the last example, but I think I will not really solving it. Just giving you for um, to think. Maybe I'm giving you two example. Maybe we can try to solve it on Friday. Okay. Okay. That's. Yeah, let me put here first the question. If you have the textbook, you can check how the solution is. But if not, then we can have some time to check and to work on together. Okay. Yeah, you can maybe if you want to take a picture or maybe you want to write down the questions. So again, I inform you. Okay. Uh, there are still, I think, two students who are not using their real names in the quiz. So I want to know who, because I want to give you the score. But if not, then I will let it as 0. Okay. I already announced on, I think in the Moodle. Check the Moodle. Okay, check the Moodle, the last Moodle. I put the name there. You put that name on the quiz, and I check it's not in our class. And I think you put in the code that are supposed to be the code for the quiz itself. So I'm confused on how your on your real name and student ID. And for others who are not getting the quiz, okay, I hope you get it right next quiz. Please be careful. Read the description carefully. If you need to submit also the paper, then you need to prepare it as well. Uh, Actually, for the first quiz, I don't mind to have like, because it's more, it has restriction on time. So I don't mind if you are preparing not really well in the paper. That's okay. I just want to see how the process is, and it doesn't need to be written really smooth. Okay, it's okay if it's quite messy. It's okay. It's okay, and that's good. That's good. Okay, this is two example. So okay, for example 4, this is similar with the ladder. You are going to use the Pythagorean if you want to solve this by yourself and check that out. And this one is having a triangle, but you need to check how you can you can relate the triangle. Okay. Okay. Now it's 9:50. I will move to our feedback time. So I hope you're ready. Okay. Let me check. Okay, that will be our feedback time. When is going to be the midterm? Perhaps the third week of November or last week of November. Okay, we will have a little bit delay for our schedule. I think. I think. Okay. Yes. Yes. Uh-huh. Here. Oh, midterm. Yeah, midterm will be chapter 1, 2, 3, 4. You mean how complex will be, or what? Yeah, you need to keep in mind. I will not give any question. Okay. Okay, let's see who are joining. Okay, I think we can start. Okay, we can start. We can start. Okay, let's see. I hope I give the time enough. Okay, at least 50 or 60, the least seconds, and I think more. Okay, get ready. 3, 2, 1. Okay, let's start. Okay, if you remember the last discussion, I give you quite time. So if you are not sure, you can still checking your notes eventually if you want to check your notes. I think this is easy, right? I think this one should be shorter. The time should be 20 or 30. Ah, okay. Okay, it's false. Okay. Okay, guys. Why you guys choose true? Okay. Oh, oh, 27 again. Oh, good, good. Okay, 3, 2, 1. Okay, let's start. Write the final result only. Okay, write the final result only. I give, I think, too much time. I think 1 minute is enough. I'm giving you 120 something. Okay, 20, 19, okay. 15, 15 seconds left. 10, 10 seconds. 9. Okay, 5 seconds. Okay. Random answer, random answer. Okay, time's up. Okay. Okay. Right. Okay. A lot of you get the correct answer. See who was going to be. Oh, okay. Okay. Okay, get ready for this third one. 3, 2, 1, let's start. Okay, write in the form of bracket A, B, bracket. You need to include the bracket, okay? Include the bracket. And no space, no space, okay, no space. Okay, 45. One, 30, 29, 28, 37. Okay, 20 seconds. 17, 16, 15. Okay, 10 seconds, 10 seconds. Okay, 5, 4, 3, 2, 1. Yeah, I already prepare for you if you forget the bracket, so it's also correct. Oh, okay. Okay, congratulations, Jim. You win again. Okay. Uh, Hopefully we can meet again on Friday. Oh, by the way, Friday online. Okay, Friday will be online. Okay, Friday will be online. So I will not going into the class for Friday. So hopefully see you on Friday. Okay. Okay. Thank you. Thank you for joining the class. Yeah, you're welcome. Yeah, you're welcome, Ardian.